Introducing MOS, the Mars Orbital Space Station, our bold vision of what the future of Mars exploration can be. Over the past 8 months, our team of 7 designers, Will Bensey, Miles Johnson, Harrison Siefke, Brenden Lopez, Tyler Wilke, Jake Kinczel, and Gilbert Rodriguez, have designed and innovated MOS to be a template for the future of space travel. Our main mission objective is to create a hub for incoming and outgoing scientists and astronauts, to make a staging base for future exploration on Mars. MOS is going to be a space laboratory, an orbital observation unit, serve short and long-term storage, and it's going to be a place where future astronauts can stop and perform missions on the surface of Mars and be that staging base for them. In short, MOS is not your average satellite. This is a plan, a big vision to create something for the future of space travel. Phase 1 encompasses the launch of MOS into low Earth orbit. We will be launching MOS out of Kennedy Space Center in Cape Canaveral, Florida. Our mission will begin on May 4th, 2022, with a 42-day window to load all components into our launch rocket by the June 16th, 2022 launch date. We will be using SpaceX's Starship and Super Heavy rocket. Being over 120 meters tall, Starship is capable of carrying over 100 tons into orbit, thus making it compatible of carrying our 90,000 kilogram MOS into low Earth orbit. Phase 2 encompasses the assembly of MOS in conjunction with the International Space Station while in low Earth orbit. While in LEO, MOS will be communicating via the Tracking and Data Relay Satellite System, or TDRS for short. During its 100 days being assembled in LEO, MOS will relay communications to TDRS satellites in geosynchronous orbit, who will then relay communication to ground stations in White Sands, New Mexico, and Guam. It is during this time multiple safety checks will be performed to ensure MOS can withstand the harsh environment of space, such as the temperature fluctuations from negative 173 Celsius to 393 degrees Celsius. Phase 3 encompasses the home and transfer of MOS from low Earth orbit to Mars using 3 X-3 ion thrusters. Beginning on September 23, 2022, this 259-day portion of our mission will communicate via the Deep Space Network, or DSN. The DSN relies on 3 very large deep space communication facilities in Goldstone, California, Madrid, Spain, and Canberra, Australia. Placed 120 degrees apart on the surface of Earth, these powerful antennas and receivers are able to provide constant round-the-clock communication with MOS while maintaining a bit error rate of less than 1 × 10 to the negative 5th at all times. Phase 4 encompasses the injection of MOS into low Mars orbit. From the period of June 9th to June 10th, 2023, the approaching MOS will end its 8.5-month home and transfer by performing an orbital insertion burn. Traveling at over 10,000 kilometers an hour, MOS will remain in a parking orbit 5,100 kilometers from the surface of Mars to carry out its intended mission. MOS is equipped with 2,400 square meters of solar cells that will provide a bare minimum of 225 kilowatts of power to MOS at all times with a minimum efficiency of 32%. MOS is equipped with a 3-meter high-gain dish antenna similar to NASA's Europa mission to Jupiter. Producing an EIRP of 81 kilowatts, MOS provides constant, efficient communication back to Earth. From everyone at the MOS team, thank you for your time and see you at launch.